Welcome to the deep dive. Today we're diving headfirst into something genuinely transformative.
Yeah.
The whole world of enterprise software,
Mm.
it's undergoing this massive, really rapid shift. It's being completely reshaped by, well, three powerful forces coming together. We're talking cloud-native architectures, pervasive automation, and of course, the really disruptive potential of artificial intelligence.
Yeah.
So our mission here in this deep dive, it's to give you a strategic analysis, really unpack the key trends shaping application development, modernization, automation, basically looking at 2025 and beyond. Think of this as your shortcut, your way to get genuinely well-informed on a topic that's just critical for every organization. And
Right.
we've distilled this from some incredibly detailed sources.
Right. And what's fascinating here, I think, is that these aren't like isolated things. They're not just separate buzzwords floating around. They are deeply interconnected. They're facets of a single holistic transformation,
Yeah.
which means, you can't really tackle them in silos. It absolutely demands a unified strategy,
Yeah.
one that addresses the tech, sure, but
Yeah.
also process and the people involved.
Right.
Because honestly, if you miss one piece of that puzzle, the whole thing can just kind of crumble.
That's such a critical point. And to really get into this, let's maybe start with the foundational shifts in how software actually gets made. I mean, for decades, so many organizations were stuck on that rigid linear waterfall methodology.
Oh, yeah.
The one with all the extensive upfront planning where one phase had to be totally done before the next could even start. It often led to these really long, drawn-out projects that just couldn't adapt easily.
Very inflexible.
But thankfully, that superstructured approach, it's largely given way now to the flexible, iterative, agile methodology. So here, development gets broken into these small sprints, right? Usually just a couple of weeks.
Mm-hmm.
And that allows for frequent delivery of actual working software, much faster adaptation if requirements change. It's a huge difference, makes teams way more responsive.
And building right on top of Agile, we then saw DevOps emerge.
Right.
And this isn't just about, buying new tools. It's really a profound cultural and procedural philosophy. It's about breaking down those old silos between the development teams and the operations teams.
Yeah, the wall of confusion.
Exactly. Fostering collaboration, fostering automation to create this continuous workflow, all the way from a developer committing code right through to production.
So if we connect this to the bigger picture, this whole progression, waterfall, then agile, now DevOps.
Yeah.
It signifies a massive strategic shift, doesn't it?
Absolutely.
We're moving from seeing software as just a project, discrete, one-off, often just a cost center,
Yeah.
to seeing it as a product. And a product is a living thing, right? It's continuously managed, improved, evolved based on user feedback, based on actual business outcomes.
That's the key to business outcomes.
Exactly.
Yeah.
So success isn't just, did we deliver on time and budget anymore? It's about the measurable business impact, the continuous value that digital product actually generates.
It's a total mindset change.
And this next development really shifts the paradigm. Parallel to these methodology changes, the actual architecture of applications has been totally revolutionized. We're finally stepping away from those big monolithic applications.
Monoliths. Yeah.
Those single, huge, tightly coupled things that are just notoriously difficult to scale or update, right?
Painful.
Instead, the industry's pretty much universally embraced microservices architecture now. So this structures an application as like a collection of small independent services. Each one does one thing well, and they talk to each other using APIs.
And that architectural shift, it goes hand in hand with cloud-native development, which importantly isn't just about running your apps in the cloud. Lots of companies do that.
Right, lift and shift.
Exactly. This is about designing them from the ground up to really exploit the cloud's inherent scalability, its elasticity, its resilience. And two key technologies really make this possible. First, you've got containers, Docker being the big one, obviously.
Think of them as these super lightweight packages. They bundle up the app, all its dependencies, guarantee it runs the same way everywhere.
Consistency.
Exactly. And the market for this stuff is just exploding, projected to go from, $5.8 billion this year to over $31.5 billion by 2030. It's huge growth.
Wow.
And this growth, it isn't just about efficiency. It really signifies a fundamental shift in how organizations think about managing complexity at scale. You're moving from managing individual servers to orchestrating whole fleets of these micro applications seamlessly.
And that orchestration piece.
That's where Kubernetes comes in. It's basically emerged as the undisputed industry standard for deploying, scaling, managing all these containerized applications across potentially vast infrastructures.
Okay, so we've gained incredible agility with microservices, containers, Kubernetes.
Yeah.
But you mentioned earlier something about a complexity tax. What exactly does that mean? Are companies ready for that?
That's a really great question. Because yes, while microservices give you amazing agility, they definitely introduce this significant complexity tax. I mean, think about it. You go from one big application to potentially dozens, maybe hundreds of little services all interacting.
Right.
That creates whole new challenges that just didn't exist in the monolith world. Like, how do services find each other securely? How do they talk to each other? How do you manage all the network traffic efficiently?
Debugging must be a nightmare.
Oh, exactly. How do you trace one single user request that might hop across, say, 10 different services? These are deep technical challenges, and they demand significant investment in a pretty sophisticated ecosystem of tools for management and observability.
Like what kind of tools?
Things like service meshes. Istio is a popular one. Robust, centralized logging, monitoring platforms. Without that kind of tooling, honestly, the agility gains can just get swallowed up by operational chaos.
That makes perfect sense. So given all this underlying complexity, what does this mean for who actually gets to build the software now? We're seeing this really fascinating democratization happening with low-code, no-code platforms, LC&C.
Yeah, that's a huge trend.
And the real game changer with LC&C, it isn't just that non-developers can build some kind of app. It's that it empowers this whole new class of citizen developers. These are often people in the business units, maybe marketing, maybe HR, who have deep knowledge of their domain, but little or no formal coding experience.
Right. They know the problems intimately.
Exactly. And now they can build fully functional applications using these intuitive visual interfaces, pre-built templates. And this isn't some niche thing either. The market for LC&C is projected to absolutely surge from around $37 billion in 2025 to something like $264 billion by 2032.
It's incredible growth. But there's always a but.
Uh-oh.
This rapid rise of LC&C also brings a really critical governance challenge. Imagine the risk of shadow IT, but like on an unprecedented scale.
Right. Everyone building their own little apps everywhere.
Exactly. When business units just start creating and deploying apps independently, they might not follow corporate standards for security or data privacy or system integration. And that can lead pretty quickly to a fragmented, chaotic, and frankly insecure landscape. Just ungoverned, siloed applications all over the place.
So what's IT's role then?
Well, IT's role has to evolve. They can't just be the centralized gatekeeper always saying no.
Right.
Instead, they need to become more like the governor of this whole federated development ecosystem, which means setting up a formal governance framework, maybe a center of excellence, that provides clear guardrails, setting the rules for safe, controlled innovation.
So less gatekeepers, more city planner.
I like that. Yeah, exactly. Like the city planner, making sure everyone can build safely and things connect properly, not just everyone building sheds in their backyard.
Love it. Okay, so we've talked about building new stuff the modern way, but what about the elephant in the room for so many companies, all that existing software, the legacy systems?
Ah, yes, the legacy burden.
Which brings us to this urgent strategic imperative of modernization, because legacy applications, they're not just inefficient anymore, are they? They're actual business liabilities.
It is liabilities.
They cost a fortune to maintain, they pose massive security risks, and they just actively block a company's ability to innovate and be agile. I mean, industry analysts are calling modernization not just a good idea, but a strategic necessity. Some even say it's a condition of survival.
They're not wrong. In many cases, it really is.
So to help companies navigate this, Gartner's 7 R's of app modernization framework has become pretty much the industry standard, right, for assessing and transforming these legacy apps.
Yeah, it provides good structure for thinking about the options.
And just to give a sense of the spectrum,
Yeah.
on one end, you've got rehost, people call it lift and shift, often the fastest, cheapest option. Just move the app as is to new infrastructure, usually the cloud. But like we said, it mostly just moves the problem.
Doesn't fix the underlying issues.
Exactly. Then, way on the other end of the spectrum, you have something like re-architect. This means materially changing the app's architecture, maybe rebuilding that monolith into microservices to really unlock the full cloud-native benefits.
Much more involved.
Yeah, way more resource-intensive, but often delivers the most long-term value.
And that's a really key point that research firms like Forrester confirm. The true business value, the real ROI from modernization, it comes from those deeper efforts refactoring, re-architecting, not just the simple lift and shift. Those deeper changes are what actually reduce technical debt and fundamentally pave the way for future innovation and staying competitive.
That makes a lot of sense. So looking at some key modernization initiatives companies are actually doing, one powerful one is serverless computing, right? Often kind of function as a service or FACE.
Yeah, serverless is gaining a lot of traction.
So the idea here is you deploy and run your code without having to provision or manage any servers yourself.
Hmm.
And you only pay for the exact compute time you use, which can dramatically cut operational overhead and costs.
Yeah, the cost savings can be significant, and adoption is growing. One report found, 46% of organizations using containers are also running serverless containers now.
Wow. Okay. And another powerful trend, maybe less talked about sometimes, is WebAssembly or WASM.
Ah, WASM. Very
Oh.
interesting space.
So imagine this. Your heavy-duty desktop software, maybe a video editor, or a complex 3D modeling tool.
Things that need serious performance.
Exactly. Things once stuck on a powerful workstation. Now, with WASM, they can run directly in a standard web browser at near-native speeds. It complements JavaScript, doesn't replace it.
Right. It opens up a lot of possibilities.
I mean, think about the implications. It unlocks totally new collaborative workflows, new business models for applications that were traditionally stuck on the desktop. Suddenly, they're accessible to anyone on the team, anywhere, just through a browser.
Yeah, democratizes access to powerful tools.
So we've talked about why modernization is crucial, the frameworks like the 7Rs, some solutions like serverless and WASM. But let's be real. What are the big challenges? What makes these projects so hard?
Oh, there are definitely significant challenges. One of the biggest is just dealing with the existing technical debt.
The hidden gremlins in the code.
Exactly.
Yeah.
When you've got code that's poorly understood, maybe barely documented, which is super common in legacy systems, it's a massive hurdle. I mean, research shows that kind of debt can lead to like a 40% higher chance of modernization projects just getting canceled or failing.
Wow, 40%.
Yeah. So a successful strategy absolutely has to include formally assessing that debt and planning how to remediate it, usually incrementally. Otherwise, you're just building your shiny new house on really shaky ground.
And then, seems like we can't discuss any tech transformation without hitting the skills gap issue.
True. It's pervasive.
There's just this persistent shortage of people with deep expertise in all these modern technologies, cloud platforms, DevOps practices, containers, Kubernetes.
Absolutely true. But maybe the most significant challenge, and the one that often gets underestimated, it's organizational resistance to change. And this raises an important question, right? We talk so much about the technology, but how often do you think the human element, just that basic fear of change, is what really derails these big transformation plans?
I think it's probably the biggest factor, isn't it? Often the elephant in the room. We can have the perfect tech stack, the best plan, but if the people aren't bought in, it's just a non-starter.
Precisely. Studies actually show that as many as 70%, 70% of digital transformation initiatives fail because of this resistance.
70%, that's staggering.
It is, and it often stems from just fear of the unknown, maybe worries about jobs becoming obsolete, or simply a lack of clear communication from leadership about why this change is happening and what it means for people. And this resistance, it ties right back into the skills gap. It creates this vicious cycle.
Yeah.
Well, the lack of modern skills fuels the fear and uncertainty, right? And then that culture of fear makes it really hard to implement the very training and upskilling programs needed to close the skills gap.
I see catch-22.
Exactly. So a successful modernization strategy, it has to be a unified, human-centric program. It needs leadership that paints a compelling vision of the future, builds psychological safety, gets genuine buy-in. That's what enables effective training and upskilling. You have to show people how this change actually benefits them, not just the company's bottom line.
That's incredibly insightful. Focus on the people first.
Always.
Okay, so for all of these shifts, new development methods, modernizing old systems to really work, they need an engine, right? An operational backbone. And that's where pervasive automation comes in. At the very heart of this is the CI/CD pipeline. It's fundamental to modern development, fundamental to DevOps.
Absolutely central.
Let's just quickly break that down. CI, continuous integration. That's where developers frequently merge their code changes into a central repository.
Multiple times a day, ideally.
Right. And that automatically triggers builds automated tests. The whole point is to detect issues really early, catch problems when they're small.
Saves huge amounts of time and pain later.
And then CD, continuous delivery or deployment. This extends CI by automating the release process itself. Continuous delivery means your code is always in a deployable state, ready for a manual push if needed. Continuous deployment goes a step further, automatically deploying every validated change straight to production. No human intervention.
And the business impact of getting good at CI/CD is just transformative.
Yeah.
It fundamentally accelerates your development cycle.
Speed.
Yeah, slashes time to market, dramatically improves software quality because you're catching bugs constantly, enhances collaboration. I mean, this level of automation is what allows elite companies, think Netflix, Amazon, to deploy code literally thousands of times a day.
Thousands.
It's a massive competitive advantage. But as organizations scale, managing all these different CI/CD pipelines across different teams can get incredibly complex, which has led to this emergence of platform engineering.
Right. So these platform engineering teams, they're essentially building what are called internal developer platforms, or IDPs. And these are powerful tools that provide standardized, self-service templates for developers. They abstract away all the underlying infrastructure complexity.
Basically making it easier for developers to do their job.
Exactly. It's about improving developer velocity, giving them those paved roads instead of making them figure out the infrastructure dirt tracks every time.
A good analogy.
And underpinning all of this CI/CD goodness are some foundational automation practices like infrastructure as code, IAC.
Crucial.
This is managing and provisioning your IT infrastructure servers, networks, databases, everything through code. Using tools like Terraform or AWS CloudFormation,
Right.
it makes creating and managing environments faster, way more reliable, repeatable, ensures consistency, gets rid of that annoying configuration drift where environments slowly diverge.
Eliminates, it works on my machine.
Exactly. Then there's automated testing. This embraces that shift-left idea testing much earlier in the development lifecycle to catch defects sooner when they're cheaper to fix. But it also includes shift-right extending testing into the production environment using techniques like A/B testing or canary releases to test with real users. And the ecosystem of testing tools is just vast now.
Yeah, there's a tool for everything.
And critically, we absolutely cannot forget DevSecOps.
Security has to be built in, not built it on.
Precisely. DevSecOps integrates security practices, automated security testing, directly into the CI/CD pipeline. People call it security as code. It's a proactive way to deal with modern threats, insecure code, software supply chain attacks, making sure security isn't just an afterthought checked at the end.
It has to be part of the automated flow.
Okay, so if CI/CD is the engine for software delivery, the next maybe broader frontier that starts tying a lot of this automation together is hyperautomation.
Right, hyperautomation, coined by Gartner.
What exactly is it? Is it just more automation?
It's a bit more strategic than just automating tasks. Gartner defines it as a business-driven, disciplined approach. The goal is to rapidly identify and automate as many business and IT processes as possible. And it uses a whole suite of tools: RPA, robotic process automation, AI, machine learning, process mining, etc. Gartner actually views this trend as so critical they've called it a condition of survival for modern businesses.
Condition of survival. Wow.
Yeah. The key distinction here is that hyperautomation isn't just about automating individual discrete tasks. It aims to automate and optimize entire, complex, end-to-end business processes. And critically, it leverages AI to make intelligent decisions within those automated processes, truly optimizing the whole workflow, not just parts of it.
That sounds incredibly powerful. So what does this push towards hyperautomation mean for the role of IT itself within the broader organization?
Well, it represents a really significant convergence, I think. It allows IT to take all the expertise they've built up automating the software development lifecycle.
The CI/CD stuff? IAC.
Exactly. And now apply that same thinking, those same skills, to redesigning and automating core business operations right across the entire enterprise. Think finance processes, HR workflows, supply chain management, you name it. This fundamentally changes IT's position. It moves them from being seen often as just a support function or a cost center
Keeping the lights on.
to becoming a central driver of enterprise-wide operational excellence. They become the architects of a much more efficient, automated, interconnected organization.
A much more strategic role.
Absolutely.
And finally, let's talk about the ultimate catalyst in all of this, the one that's really poised to redefine everything. Artificial intelligence. AI's impact on software creation and the whole developer experience is just huge.
Yeah, AI is touching every part of the life cycle now.
Right. I mean, look across the SDLC. In requirements and planning, AI can analyze user feedback, maybe even automate some documentation. During design, it can offer suggestions, generate prototypes. In development itself, we have AI-powered coding assistants. GitHub Copilot is the obvious example, providing real-time code suggestions, automating boilerplate code. That's a massive time saver right there.
Huge productivity booster for many developers.
Then for testing, AI can help predict defects, generate test cases, even assist with root cause analysis when things go wrong. And in deployment and operations, we've got AI Ops, which uses machine learning for things like predictive maintenance, anomaly detection, optimizing resource usage, basically making IT operations smarter and more proactive.
It's weaving itself into the fabric of development and operations.
But this next development is particularly fascinating. It suggests a really fundamental shift in how we even interact with code. We're seeing this evolution from AI-assisted programming towards something people are calling vibe coding.
Vibe coding, yeah.
So AI-assisted programming, like we just discussed, that's where AI acts like an intelligent pair programmer, right?
Your helpful assistant.
It suggests code, spots potential bugs, speeds up repetitive stuff. But, and this is key, the human developer is still firmly in control. They're writing, reviewing, ultimately owning the final code. It enhances the workflow we already have.
Right. The human directs the AI tool.
But vibe coding. This term was coined by Andrej Karpathy, the AI researcher, early in 2025. It describes something more radical.
Yeah, it's a different paradigm.
Here, the developer's main role shifts. They focus on describing the high-level intent in natural language spoken or typed.
Just saying what they want the outcome to be.
Exactly. And the AI model is then responsible for actually generating the code, executing it, and refining it to match that intent.
It's this fast, sort of improvisational, highly iterative loop. You prompt the AI, it generates something, you look at the result, you give feedback, it refines it, back and forth.
A conversation with the code generator?
Kind of.
Wow.
And a key, maybe slightly controversial aspect Karpathy pointed out was this idea that the user might almost forget that the code even exists because they're just focused on the output, the behavior.
Forget the code exists. That sounds, well, almost magical, but also kind of unnerving. What are the real practical implications, the downsides compared to traditional coding or even just AI-assisted coding?
It can feel magical, especially for rapid iteration. But yeah, it absolutely comes with significant caveats if you compare them. Traditional programming is manual, needs deep syntax knowledge, prone to human error, but it gives you absolute control essential for complex, critical systems.
Right.
AI-assisted programming gives you smart suggestions right in your IDE, massively boosts productivity for experienced developers who still understand the underlying code. Vibe coding relies on that high-level intent. It actually demands exceptional critical thinking and really clear feedback from the user to guide the AI effectively. But, and this is the big but, the risks are substantial. You can end up with poor quality code, potential security vulnerabilities buried deep inside stuff the AI generated, code that is incredibly hard to maintain because the developer wasn't involved in crafting it block by block.
Debugging must be interesting.
Yeah, debugging challenges galore, often due to a sheer lack of architectural rigor. The AI might just patch things together without a coherent design. So, given those risks, vibe coding today seems best suited for things like rapid prototyping, maybe quickly building an MVP, or enabling non-technical people to create very simple applications.
Okay.
It is absolutely not ready for prime time in high-stakes enterprise systems. That human element of careful review, architectural design, and ownership, still paramount.
That makes perfect sense. So these AI advancements, they obviously have profound implications for the future of the software engineering role itself. What does this mean for developers today or people thinking about getting into this field?
That's a really critical question. The consensus seems to be that the demand for, let's say, junior or generalist coders, whose main job is just translating specifications directly into lines of code, that demand is likely to diminish.
Because the AI can do more of that translation.
Exactly. As AI tools get better and better at automating routine code generation, companies are finding they might need fewer engineers just to ship a particular feature. The nature of the work is definitely shifting.
So the role isn't vanishing, but it's evolving, moving up the stack.
Precisely. It's evolving towards higher level, more strategic responsibilities. The engineer who will be most valuable in the future is more like an AI architect or maybe a supervisor of automation. Their focus shifts dramatically. It's about designing scalable, resilient systems. It's about understanding how to integrate AI effectively and safely into production environments. And crucially, it's about auditing the outputs of these AI systems, checking machine-generated code for logic flaws, inefficiency, security holes.
So quality control becomes even more important.
Hugely important.
Yeah.
And they'll also need to think more cross-functionally, understand the business context much more deeply. And this evolution highlights what might be the single most critical challenge of the AI era in software development. The potential for AI to generate massive, opaque technical debt at an absolutely unprecedented speed.
Ooh, that sounds bad. AI-generated tech debt.
Think about it. AI-driven development can churn out vast quantities of code incredibly fast. But that code might be inefficient, it might be insecure, it might be poorly structured, full of hidden flaws. And because the original intent might just exist as a series of conversational prompts rather than, say, detailed design documents, debugging and evolving that code later becomes exponentially harder.
Right, you lose the why.
Exactly. Therefore, the most indispensable engineering skill going forward won't just be writing code faster. It will be the ability to effectively manage, audit, and impose architectural rigor upon AI-generated code. It's about foresight, quality control, and strategic thinking.
So pulling it all together, the central thesis of our deep dive seems to be these big trends, cloud-native development, app modernization, all this automation, and now AI, they're not separate things. They are deeply interconnected, mutually reinforcing.
Absolutely. They feed each other.
And success really does require a unified strategy that tackles all of them together. You can't just pick one.
Precisely. And the ultimate goal for many organizations should probably be investing in creating enduring digital platforms. Specifically, building out a robust internal developer platform, that IDP we talked about. That's what really transforms IT from being seen as a cost center into a true strategic enabler of agility across the entire enterprise. It provides that standardized, secure foundation for all development and innovation.
Okay, so for the technology leaders listening, trying to navigate all this, based on our deep dive, what's a concise, actionable roadmap? What should they be focusing on?
Good question. Let's try to summarize.
First, maybe conduct a strategic portfolio assessment. Use a framework like Gartner's 7Rs to figure out what to do with your existing apps, but really focus on those deeper modernization efforts. Re-architecting, refactoring, not just lift and shift.
Right. Aim for real value, not just moving the problem. Second, invest in automation as a core competency. Make CI/CD pipelines the absolute standard. Embrace infrastructure as code. Embrace automated testing everywhere.
Table stakes now. Third, embrace AI, but do it pragmatically and strategically. Embed those AI assistants. Leverage AI ops for smarter operations. But treat vibe coding as what it is right now, an experimental tool, mostly for prototyping. Focus on cultivating that crucial AI architect skill set internally.
Yeah, manage the hype versus the reality. And fourth, critically, proactively manage both technical and cultural debt. Set up formal processes to assess and remediate technical debt. And launch comprehensive, human-centric change management programs. Paint that compelling vision, provide robust training, focus on the people side of change.
Excellent summary. So looking even further out now, maybe beyond the immediate horizon, towards 2030 or so, this raises an important question, doesn't it? What other big disruptions are already starting to form out there?
Yeah, thinking further ahead. Well, one area, though still very early days, is quantum computing.
Ah, quantum.
Its main impact in the medium term is probably security. It has the potential to eventually break much of the encryption we rely on today. So starting to think about and plan the transition to quantum-resistant cryptography, that's going to become a critical future priority for security teams.
Okay, good one to have on the radar. Anything else?
Another growing area is the intersection of ethical AI and sustainability. As AI models get more powerful, auditing them for bias, fairness, and unintended consequences, that kind of ethical AI testing becomes increasingly important. We need to build responsible AI. And alongside that, there's growing pressure around sustainable or green cloud practices. Thinking about the huge energy consumption of data centers, prioritizing renewable energy sources, that's becoming a bigger factor in technology decisions.
Right, the environmental footprint of all this tech.
Exactly. It's about building a responsible and sustainable future, not just a technologically advanced one.
So if there's one defining characteristic of this whole modern technological era, it really is just the accelerating pace of change, isn't it? It just keeps getting faster.
Relentlessly faster.
Which means the role of technology leaders has fundamentally evolved. It's not just about managing stable infrastructure anymore. It's about being champions of continuous strategic transformation, changing the entire digital DNA of the enterprise, mastering this convergence of cloud, automation, and AI. It isn't just about survival anymore. It's about enabling your organization to not just adapt, but to truly thrive in this incredibly exciting, constantly changing landscape.